Hello, this is Mrs. Thompson. This is lesson A01, Square Roots and Perfect Squares. If you're in your notebook and your workbook, this is page 3. These are our starting out standards we're going to look at. I can identify and evaluate square roots or perfect squares. I can understand the concept of a square root and understand squaring a number and taking its square root. So squaring a number meaning taking 4 and squaring it, and taking the square root of a number, meaning the square root of 4, are going to be inverses. So if I look at 4 squared is going to be 16, 4 times 4. And I'm going to change this right now. Instead of taking the square root of 4, I'm going to say the square root of 16. And the square root of 16, what number times itself gives us 16? Is 4. So inverses, kind of like addition and subtraction, multiplication and division. If you turn back in your workbook, what you're going to see on page, on the very first page of your notes workbook that you're going to get, you're going to see these are our standards that we are working on for our proficiency standards, our essential learner outcomes. You're going to see those on the first 2 pages. So these are our different essential outcomes on page 1 and 2 of your notes, and we are now on page 3. So make sure you look at those. That's kind of how we're grading your test. We are asked to find the lengths of the square. So it tells us the area is 1 square unit and this area is 4 square units. So if I'm looking at the length of the side, that is in between these 2 dots, this first one, the length is going to be 1 unit. Now, if I would have told you that this was 1 centimeter squared, or sometimes written out this way, 4 square centimeters, then our answer would be in centimeters. So if I told you it was 4 square centimeters, then we would look at the length of the side, and again, you're looking between the dots, and this would be 2 centimeters. It says, well, we want to make a prediction. If I drew a square with an area of 16, and I could actually do that up here, right? I could do an area of 16 right here. I can count those squares inside by dividing it up. What would we think the side length of that square should be? And if you are looking at that between the dots, hopefully you've realized and filled in your notes that this would be 4 centimeters. Or we might just say 4 units because we don't really know the unit of measure. Now, what's nice about this is you have a little bit of white space below in your notes, and what I would like for you to add is I would like you to put the word area, and I would like you to put the word side length. And when I look at those 2 words, what I am thinking about is that I actually want to, is that when I look at those, what I actually want to do is if I told you, oh, the side length happens to be 3 centimeters, you would tell me the area is 9 square centimeters. If I said, and if you know your multiplication facts, the area is 49 square centimeters, you might say, what number times itself gives me 49? 7 centimeters. So I'm going to put one down here for you to try. If the area happened to be 100 square centimeters, I would like you to write down in your notes what you think the side length is. And then if the side length was 5 centimeters, what do you think it would be in square centimeters? So pause the video and please fill those in. Should have had 10 centimeters, and you should have had 25 square. So now we're going to be looking at the side lengths and areas. We're going to talk about this a little more. To find the area of a square, you multiply the 2 side lengths together. So when this says 4 squared, what they really mean is that is 4 times 4. That second means to tell you that you have 2 4s. So since the same side length, because it's a square, we usually say that you are squaring the side length. So as we look at these next 2, first thing, notice this one, you know the side length is 7. So think about what we just said for our area. We're going to take the side times the side, 7 times 7. So if we are looking at that, and this next one, we can't see the side length, and the confusing thing sometimes, people think we want to count the dots. We don't. We're counting the lengths. So this is 1, this is 2, and this is 3. So we have 3 units. So if we are looking at the first one, we would say our first one has an area of 9 square units, and our second one, we want to use the label they give us, 49 square meters. Now, I will notice that some of you will sometimes prefer to not write this word square, and you will do something like this. You'll do meters, and you'll put to the second power. This is okay. This is wrong if you put the second here, because that means 49 times 49. So you just got to be really careful where you put that. So sometimes writing the word square is better for some of you. This is a list of squares that you actually need to memorize. So what I'm going to do is I will, at one point, you'll see me have a quiz that'll look something like this. And I'll have all of this covered up, and I'll say, okay, tell me, what is 1 squared, 2 squared, 3 squared? And if you know those multiplication facts, this is going to be pretty easy for you. Where you might start struggling is when you get up to 12 or maybe 13. What's nice is if you know from 12 to 13, is that now this one, 196, is just 169, just switching around those last 2 digits. We will talk later in this unit about some other patterns that you might see as you're going up this table. Right now, we're going to watch this really short video about what is a perfect square, and they just explain a little more about what it is. So as you are taking a look at this, and
that is the square of an integer. In other words, we could take an integer and square it, and that resulting number is a perfect square. Now let's take an example. 16. 16 is a perfect square because it can be broken down into 4 times 4. In other words, we take the integer 4 and multiply it by itself. Or we take 4 squared. When we take 4 squared, that resulting number of 16 is a perfect square. Now there are an infinite number of perfect squares, but let's list off just a few to get an idea of what they look like. 4 is a perfect square because it can be broken down into 2 times 2. In other words, we take the integer 2 and square it and get the perfect square of 4. 9 is also a perfect square because it can be broken down into 3 times 3. We already know that 16 is a perfect square. It's 4 times 4. 25 is also a perfect square because it's 5 times 5. And 36 is a perfect square because it's 6 times 6. Let's take a couple more. Because it's 10 squared. Each one of these numbers on the left-hand side of our equal sign is a perfect square because it can be broken down into the square of an integer. So remember, if you have the square of an integer, that resulting number is called a perfect square.
So when we think about that, we are now filling in what is this perfect square. You should be on the top of page 4 is where you see this list and what you want to fill in, and you may need to pause the video at times. So when you're looking at this, pause that video if you need to take a little extra time to write down what is a perfect square. They use the word integer, okay? It's a square of an integer like 1, 2, 3, 4, which means if we could take -2 times -2, that does give us a +4, so perfect square. It says these are also the areas of all the squares that you can draw with whole number side lengths. So sometimes we're going to talk about some tilted squares, and those are not going to be perfect. So in the vocabulary, if you know the area of a square, you can work backwards to find the side length of one side by using the square root. In other words, if you take a perfect square and ask what number was squared to get this, meaning what number times itself gives you that length. The square root of a number is a value that multiplied by itself is a given number. Example, 4 times 4 equals 16, so the square root of 16 is 4. 4 squared is 16, the square root of 16 is 4. Note that negative 4 times negative 4 is also 16, so negative 4 is also a square root of 16. Now, how that comes about is if I say what number squared is equal to 16, you could tell me x could be 4, and someone else could tell me that it could also be negative 4. And you will see sometimes in mathematics that they will write this way, plus negative 4. So when you're thinking about that, this is the symbol that we use. It's called the radical symbol. So not radical like your parents are thinking you're way out there, but radical, used in terms of mathematics. It means you take the square root of the number beneath it. It says if a is equal to s squared, which is the side squared, then the side is equal to the square root of the area. So a lot of times I like to have students write in their notes that if the area is equal, and this would be our side squared, or we could say side times side, and then we say that the side is equal to the square root of our area. That might help you as you're writing that in your notes. So now, again, if you need to pause it or go back and look at something, please do so. It says, find the length of the sides of the squares below, using the concept of square roots. The area is 36, if I was looking at that. And you might want to try these first on your own and then pause the video and see. We should see 6 inches. The area is 4 square centimeters. Again, try these two writing them in. We should have 2 centimeters, and this one would be 12 centimeters. It says here's a list of all the square roots. So when we think about our square roots, okay, all of the square roots and their perfect squares that you are going to memorize. You want to memorize these two. So you need to know the square root of 1 is 1. The square root of 25 is 5. The square root of 81 is 9. Not just that first list that we saw. Now, if we are taking a look at this, we are on the bottom of page 5 right now, and it says, are there negative square roots? And the answer is yes. It says the number 5 and negative 5 are both square roots of 25 because when you square each of them, you get 25, which is true. 5 times 5 equals 25, and negative 5 times negative 5 gives us 25. Every positive root has 2 square roots, a positive and a negative, but 0 only has 0 if we are looking at that. So when we're looking at it, square root of 25 is 5. This negative out in front tells us to take the opposite of square root of 5, and that is going to be our negative square root when we are taking a look at that. Our radical, our radicand, the number underneath is called the radicand. It says the radicand cannot be a negative number because there are no real numbers that give us a negative answer when you square it. So if you think, oh, well, negative 5. Nope, that gives us positive 25. Later, when you get into Algebra 2, you'll talk about this special kind of number. It's called imaginary. Not one of our problems right now. So right now, on your notes, you should be filling in, and I would like you to try these and just pause the video and answer the questions, and then you're going to see me answering the questions. The first one, square root of 49, 7. Square root of 36, 6. Negative, opposite, square root of 100, negative 10. Notice these next two are fractions. You're going to keep the answer as a fraction. So square root of 4 is 2, square root of 49, 7, 2 sevenths. Square root of 1 is 1, square root of 9 is 3, 1/3. Now your homework tonight is going to look a lot like this. Again, thinking about these and in reverse if we can go back and forth. So it says look at the tables in the two numbers. They show taking the square root of a number or taking the square of a number in square roots. These are called, we mentioned it earlier, inverses. This means one undoes the other one, like addition, subtraction. So as we are finishing off our notes, just to make sure that as you are looking at this, that you understand that if I take the square root of something squared, it equals that number. Now that's super nice. If I ever see something ugly like this, square root of 31 squared, I don't want to use my calculator, which we're going to show you later. That's just going to be 31 because these two things, they undo each other. As you take a look, I have the assignment here. So the first ones, I just want to mention it just a little bit. Other teachers will be doing other videos. They may or may not talk about the assignments. So if we are taking a look at this, I am asking you to try and find the area. So you might write area and put your answer. Remember, the answer key will be in the back. Here you're asked to square each one, find the positive roots, and then evaluate. Now, if you need and you get stuck, remember you can look at that list of your perfect squares for some of those later ones. Here it says a square has an area of 121. What is the side length? So you're going to tell me the side, and it has to be in feet. So don't forget the units when you do these. As you take a look at those next couple of questions, again, make sure you use the units that was given. There are only one page in your assignment that you're going to do. Hopefully that makes sense, and have a great day.